Hi, thanks for joining. In this video, we will cover the virtualization engine in Timbr, how it works, when to use it, and how to debug it if needed. In this example, we'll use MySQL and Postgres databases, but this applies to any other database you connect to the Timbr platform as well. So let's begin. We'll start with the data model and create a concept called customer. For the sake of this example, the concept will only have two properties, customer ID and customer name. The concept won't have any data mapped to it. Instead, we will add mappings to its subconcepts, which will classify two types of customers, those from the US and those from Europe. We'll start with the US customer concept, and we'll add a unique property called customer segment. Next, we'll map our MySQL data to the US customer concept we've just created. We'll select the MySQL data source and choose the relevant schema and table. We won't apply any data transformations at this stage as the table was already cleaned and fits our semantic model. Great! Now we can click on Fetch Sample Data from the customer concept and get the data from MySQL that's mapped to the US customer concept. Let's continue and add our Europe customer concept. This time, we will add a unique property called gender, since that's the information we have about customers from Europe in the Postgres dataset. In the mapping stage, we will choose the Postgres data source as well as the relevant table that has the data about customers from Europe. This time, we will apply a concat function since we defined a full name in the customer concept instead of using the separated first name and last name as appears in the Postgres dataset. Okay, so let's see what we have in the customer concept hierarchy. We have the customer concept, which has two properties, customer ID and name, and two subconcepts that inherit those properties but also have a unique property in each subconcept, customer segment for the US customer and gender for the Europe customer. Let's click on the view lineage from the customer concept to see where the data comes from. Here, we can clearly see that the data of the US customer concept is coming from the MySQL database, while the data of the Europe customer is coming from Postgres. Now, when fetching sample data from the customer concept, Timbr automatically brings data from both sources. So now that we got the model covered with a bottoms-up data mapping, let's move over to the SQL editor and see how we can query this model. We'll begin by choosing the knowledge graph. And as you can see, the default data source is Spark Virtualization. We can click on the data source box and change the data source we want to query. But for now, we'll leave it on the Spark Virtualization and run a simple query of select star from Timbr.customer. You can see the results include data from both subconcepts, US customer and Europe customer. If we click on the Explain Query button, we can see that Timbr automatically adds the union statements to combine the data from Postgres and MySQL. It's important to mention that Timbr runs natively on Spark and Databricks. We can change the data source and use Databricks as our virtualization engine for the same query and get the same results. Companies can decide according to their preferences which virtualization engine they'd like to use. If we were to query the US customer concept, instead of customer, we would only get data from MySQL. And when clicking on Explain Query, we can see Timbr pushing down the query only to the MySQL database. The same would go for the Europe customer concept and Postgres. But what would happen if we query the customer concept again while having only the MySQL database chosen? Well, let's see. We'll choose MySQL in the data source box and run the same query of select star from Timbr.customer. As you can see, Timbr only fetched data from the MySQL data source. Therefore, we can only see US customer data. The same goes for Europe customer data when choosing Postgres as the data source. So these scenarios are clear. When we use a virtualization data source and query the high-level concept customer, Timbr pushes down the query to all the mapped databases and unions the information on the virtualization level. However, when selecting a specific database and running a query, Timbr will push down the query only to that source and get the results from there only. If we choose Postgres as the data source and query the US customer concept that is mapped to MySQL, we won't get any results, as we can see here, since the table doesn't exist in the Postgres database. Another important scenario is when we query the customer concept and apply a filter. In this case, Timbr pushes down the query with the filters as pre-predicate pushdown and unions the results only after they were filtered on the database level. This makes the virtualization much more efficient. To better understand this scenario, we will query the customer concept with a where clause using the virtualization. Great! Now that we got our results, let's head over to the query search window to see which queries Timbr executed. Here, we can see 3 queries, the one we just executed with the where clause, as well as the queries that were pushed down to MySQL and Postgres. We can also see in the query box that both queries include the filter we added. I hope this video helped you understand how the virtualization works and how to query the semantic models in Timbr using different data sources for different queries. Feel free to write to us if you have any questions at all. I invite you to check out additional tutorial videos to learn how to make the best use out of the Timbr platform. We'll see you in our next videos. Thanks for watching and have a great day.